Our first speaker is Chris Barker from NOAA. He's going to talk about the suite of modeling tools that are contained within the general NOAA oil model environment. Chris, are you out there and ready to go?
All right, so I'm here to talk to you a little bit about the GNOME suite of oil spill modeling tools. I'm going to whip through this because I'd like to try to get to a little bit of a demo. But talk to you briefly about kind of who we are and why we develop software, and then some of the pieces of the GNOME suite. So NOAA's Emergency Response Division, we provide 24/7 scientific support for oil and hazardous material releases. So this is kind of our mission laid out in these bullet points. But the basic idea is that when there's a spill, we are the sort of federally designated scientific support for the Federal Unseen Coordinator. I myself have been there since 1998. My sort of primary response role is part of the Oceanographer on duty team. So that means I get called in the middle of the night for modeling and scientific support for chemical spills. When we're not working on spills, I'm leading the development of the GNOME suite. So at ERD, we do most of our model development in-house. This is so the people who are developing the models and the people who are using the models operationally are on the same team and often the same people. And that means we really understand the strengths and limitations of our models. Sometimes we even need to add features or fix bugs on the fly in the middle of a response if something goes bad. And it means our tools are developed specifically to support response. So we have a very kind of response focus on what our models do. So the core piece of the GNOME suite is GNOME itself, which is an integrated fate and transport model. So it answers that basic question of where will the oil go, the transport, and how will that oil change as it's exposed to the environment, the fate portion. And the components of GNOME are what we call PyGNOME because it's written in the Python programming language. This is the computational engine itself, and then it provides a scripting environment. So you can write relatively easily in the Python scripting language. You can automatically run GNOME. So you would want to do this if you're a programming geek, but also if you have large modeling programs, or you want to do batch processing, or indeed, if you want to customize the model itself, then you can get in there and do that. And then for the rest of us that aren't programming geeks, we've developed WebGNOME, which is a browser-based graphical front end. So there's a NOAA hosted version of this. It's available to the public. I'll be showing you. That version is suitable for planning, training, drills, education, things like that. I don't recommend you rely on it for sort of operational purposes because it is just our publicly facing server. It may or may not be working at any given moment. And we really don't have the resources to support large scale problems. But you have the option of running the whole system yourself on your own systems, and then you can do anything you want with it. So the transport modeling framework is a Lagrangian element or particle tacking approach. This is how most oil spill models work. It's nice because there's no grid size dependence. It can preserve sharp gradients. We can couple it to 3D transport. There's no numerical diffusion. And I guess it's not mentioned here, but it's also very scalable. So you can use basically the same modeling framework for small scale problems as well as, North Pacific scale problems. The fate modeling framework for how the model transform, oil is a really complicated material. It's made up of thousands of individual compounds, and there's really no way we could be modeling each of those compounds and what's going on with them. So our solution is what's called a pseudo-component approach, where you break the oil down into some manageable number of components that sort of represent collections of compounds that have similar behavior. These are usually based on distillation cuts. So you have essentially each pseudo-component has a representative boiling point and can therefore you can model evaporation appropriately. And we're also looking into using sort of Sarah composition, other things to help better model emulsification. But for response purposes, we use usually only about 7, a fairly small number of pseudo-components because that captures the bulk behavior fairly well. The weathering algorithms included we've got spreading, evaporation, natural dispersion, sedimentation, and emulsion formation. And this is all pretty much the same algorithms that were in ADIOS 2 with some just minor modifications. And we also have now included a biodegradation algorithm and a dissolution algorithm. These are still kind of experimental and aren't sort of turned on in the operational version, but the code is there, and we're hoping to make it more operational in the future. So I mentioned PyGNOME briefly. This is essentially, it's the computational core. It's written in a combination of Python and C++. It's also a flexible particle tracking framework. So if you're interested in things that drift around the ocean other than oil, it can be adaptable to a lot of things. We've used it for marine debris transport, fish and coral larvae, harmful algal blooms, and stuff like that. And all this code is open source and available on GitHub. So when you actually have to do some modeling during a spill response, we kind of like to say you know very little and much of what you know is wrong. On the slide here is a little example from, I don't know, I think it's about a year ago, but, and this is kind of the typical information we'll get at the beginning of a spill. We'll know that there is a discharging wellhead. It was observed to be spraying petroleum. Do we know what kind? Who knows? Maybe a crude, probably not. And that's really kind of all the information we tend to have. But at the end of the day, if you want to model this, you need to know the spill volume, release duration, spill location, physical properties of the oil, winds and waves, ocean currents forecasts. So issue about spill volume, release, duration, location, that all depends on that spill you want to model. And then we get to physical properties of the oil. So if we want to be able to understand how the soil is going to behave in the environment, and particularly if we want to actually model how it's going to weather and change, we need to know about the oil. And for this, we have a tool called the ADIOS Oil Database. We've been doing a lot of active development on this. There is a test version live right now. We hope to have it be kind of officially live very soon. So this database includes 1,700 oil records, which is all the data that was in ADIOS 2, as well as all the latest data from Environment and Climate Change Canada, a set of assays from ExxonMobil, another set of data from the Norwegian Met Office. And as we stabilize the software, we're going to be collecting more and more data. Right now, actually, we are working on a project funded by the Canadian Multi-Partner Research Institute to collect oil samples of the types of oils that we don't have currently well represented in the database, and those are being sent to the lab at Louisiana State for analysis and will be included in the database. So the key of this is a public database. Anyone can view it, anyone can contribute to it, and soon we'll be able to directly use it in the GNOME model. I'm going to actually just really quickly go to it live. I'm going to pause for a second and have somebody acknowledge that I'm not speaking into the ether. So can you all hear me?
Yes, we can hear you.
Good. It's always hard to do when you're not sure. So this, again, this is at https, you need that, adios-stage.orr.noaa.gov. And this provides this just full database of oils. You can see it says there's 1,790 results shown now. But let's say you're interested in oils from California. Now we have 63 results, and these are all assorted oils from California. And then if you click on one of these, you get a whole lot of data about it. So right up front, your basic physical properties, density, viscosity, interfacial tension, that kind of thing. Then we have the distillation cuts, which is very important if you want to properly model evaporation processes. You need that. And then this particular data is from the Environment Canada lab, and they do a really great job of artificially weathering the oil in the lab and then measuring its properties again. So you can look and see how the density and viscosity change with the degree of weathering in the lab. And then also, if it's available, we have information about environmental behavior, which includes chemical dispersibility, if they've done, say, the swirling flask test, as well as if the oil has emulsified, they managed to create an emulsion, they have the properties of that emulsion. So a lot of information here. Some subset of it can be used by our models, and the rest of it is still useful to just kind of understand this oil and how it might behave in the environment. So let's see, I just showed you all that. So then the other piece, if you want to try to model an oil spill, is you need to know something about what's going on with the winds and the waves and the ocean forecasts. And for that, we have what's known as GOODS, the GNOME Online Oceanographic Data Server. I believe I've got that up here too. And so this is an example. I just actually was doing a little test case earlier today. This particular example, we're getting ocean currents from, actually this is getting the winds from the NOAA's North American model. And what GOODS does is it gives you kind of one-stop shopping for all the kind of data sources that we typically use for response. So this is data that's operationally available, includes global ocean currents, regional current models, wind data, shoreline base maps that you need to run the model. So anything that's kind of available operationally, we can get through this system, and this is made public. And what it does is it, first of all, it helps you find things, because all these are served up by different people in different places, and it's very hard to keep track of. And also what it does is it will convert the data from whatever format it is in at the source to a format that the GNOME system can understand. Another tool I just want, this is a minor little thing that's part of the GNOME suite, is what we call NUCOAST, or the Noit unit converter for oil spills. You know, there are any number of unit converters out there. And they all will do all kinds of things, but in the oil spill biz, we have some really weird units, you know, like API, or the skimmer people like to talk about barrels per acre. And so this has all the weirdo units that we use in the oil spill biz, but not the weirdo units that other people use. It's a little harder to, a little easier to keep track of. It also has some nifty features like an oil quantity converter. If somebody tells you that there were a certain number of metric tons, for instance, of a fuel oil number 4, then you can look at this and say, okay, that's about 2,000 barrels. So that's very helpful when you're dealing with kind of the international community that works in different quantities. So all the nifty things you need. This is downloadable from our website and available as a desktop application for Windows and Macintosh. This one I'm going to touch on really briefly because I don't have that much time, but it's CAFE, the Chemical and Aquatic Fate and Effects Database. This is a database system that includes toxicity data for a massive number of different chemicals and different species that are affected, as well as a certain amount of toxicity information about different oils and dispersants and the chemically dispersed oil combination. We use this most frequently for chemical spills rather than oil spills, but it's one place to go and get some idea of how toxic this particular material is. And in particular, if there is enough data, it will create one of these, which is known as a species sensitivity distribution graph. And this is the idea that different species and different life stages are more or less sensitive to a particular chemical. And you can kind of fit this to a curve, which can then help you get an idea of how sort of toxic it is, you know, in general, when you don't know exactly what species, or if you don't have data for the species of concern. So CAFE is available at https://cafe.orr.noaa.gov. It also now has a web front interface. So it really gives you access to both fate and effects information for chemicals. Also want to mention the trajectory analysis planner. So this is a way to get a statistical assessment of oil spill transport. So if you have a spill in a particular location, where might that actually go under the different kinds of winds and current conditions that might exist in that region? This is really, really important for planning because you don't know which way the wind's going to be blowing or which way the currents will be flowing when some spill might happen in the future. And so the way we do this is we collect hindcast data, a collection of measured wind data, for instance, and a hindcast model run in general. So this picture right here is for Southern California. This is a location we just recently completed with some funding from Bessie. So they funded a long hindcast of the currents in Southern California, and then we used that, ran it through GNOME in a batch mode to generate these statistics. This also has recently been made as a web interface. So it's currently still in a test mode, but you can find it at tap-stage.orr.noaa.gov. And that gives you kind of one place to go and get the data you need for planning. So now kind of the main feature, and I have to say I'm in full screen mode, so I'm not sure how I'm doing on time. How much time do I have, Jed?
You have 3 minutes and 37 seconds.
Okay, so I can't do a whole lot of live demo here, but I'm gonna just tell you about WebGNOME briefly, and I think I am gonna just go to it rather than talking about it. So this is WebGNOME. In this particular case, it's all set up for San Francisco Bay. This is all with data that I just downloaded from Goods today. So I got the shoreline, I got the currents, I got wind data from the model. And you can see, I've already run it in this case, but it runs pretty quickly. And then you can kind of look back and forth and see how it all goes. I'm just going to sort of show you that if you start at the beginning with GNOME, you have this screen, and you have really a couple of different ways you can start the model. You can do a manual setup, which is what I just did there, and that's where you have to provide the wind data, the shoreline data, the currents, and all that stuff. Or you can load a location. And here we have, I think it's 27 or so different locations, mostly around the United States, that are all pre-configured and set up and ready to go for that location. You do want to be careful about this because being pre-configured, it means it's sort of representing climatologically what typically happens in that region. If you actually have a spill, then you may be facing unusual conditions that we don't capture. So you want to be careful about that. And then the final mode I want to just point to you quickly is the oil fate wizard. And this, if any of you remember the old Adios 2 model, is similar to that, where you can just set up some basic settings of your scenario, pick an oil, give wind conditions, water conditions, and get an oil weathering run right from there. And I'm probably about out of time here. See if I have. There we go. That's the results of an oil weathering run, just as a demo. So I'm going to stop here and see if there's any time for questions.
Okay, well, thank you, Chris. I see there are a couple of questions in the Q&A box. Lindsay, Jenna?
Yes, first question from Bill Adams. Are there any sets of location data for Canada?
No. We don't have any pre-configured locations for Canada, and actually in terms of data, we do have coarse data for Canada available on Goods from the global models, but currently not anything finer scale. We do work fairly closely with the Canadians on modeling, but they're not kind of quite as, they don't make it easy to get their data available freely. So it can be used in Canada for sure, but you've got to get the wind and current data yourself somehow.
Thanks. And there's one more question. Do you foresee more widespread use of TAP for simulating potentially impacted shoreline and industry contingency plans? And typically, industry contingency plans in Alaska only contain one realization of a spill trajectory in the scenario section. So more would be better.
Yeah, I fully agree. We have been doing various versions of the TAP system for 20 years. It was one of the first projects I started working on when I started working at NOAA. So it's still been a little hard to kind of get it into operation. So I wish people would use it more. But you know, one of the problems is that with the industry, they meet the requirements that, you know, they are told to meet. And at this point, we don't have any regulatory requirement for statistical analysis. As far as Alaska is concerned, we do have a TAP for the North Slope. So there is information available there if people want to make use of it.
Okay, well, thank you, Chris. Despite technical difficulty, you managed to pull it off and give us an excellent presentation.
There's one more question, Judd, for
okay.
Chris. Is there time for, well, please, if you can, pull up a quick demo for exporting a video from WebGNOME?
You know, I'm sorry to say that is actually a little clunky right now and not that reliable. So you're best off actually just using screen capture software to make the video yourself.
Okay.
That's all we have. Thanks.
Okay, well, again, thank you, Chris, for pulling it off, and we appreciate everything you just shown us.
Sorry, one more question.
Oh, let's see.
From Roy Kim, are there trainings for GNOME, Adios, etc. available?
No, not really. We've done that in the past, but we don't have anything formal set up at this point. So yeah, we've got that there's help documentation online, which is a little limited, but it's a good starting place. And then if you send us email questions, we will answer them.